get started, we want to engage you in a little bit of mathematics, our fun part of the day. And so we would like, if you have a piece of paper, oops, I just noticed that I am not moving forward in my slide deck, so my apologies. So hopefully you're seeing this on page 1, and we will be referring to this document. Again, my apologies for not moving forward. But we're going to start by doing some mathematics and give us a kind of a shared experience with these standards for mathematical practice. And so we're going to think about a task from a typical 3rd grade classroom. But again, think about the behaviors and the thinking that's going into this and how it might apply to each and every child, regardless of grade level. So if you have a piece of paper and a pencil next to you, or you could just think this through, this is something we might give a typical 3rd grader. So the directions are to think about 3 times 4 and show it using a visual model. So what does a picture of 3 times 4 look like to you? And then if you can, write a story problem that matches the visual model that you just drew and your reasoning. So I am going to literally give you 42 seconds to pause and give you some think time on that. And I will come back in 42. Okay, I'm going to jump back in here. And of course, we would give our 3rd graders more time than 42 seconds. But as adults, we just want to keep it kind of moving along here. But I wanted to share with you a few ways that our 3rd graders might think about this. And you might have thought about it this way yourself. So I'm going to advance my slide. So one of the ways that you might have thought, or our students might think about it, is in this kind of circle and dots model, right? So I have 3 friends, I have 4 friends, I'm giving 4 pieces of candy to each friend. How many pieces of candy did I give away? Now, a student might think of it a different way, or a similar way, but thinking about the numbers in a different way, where in this case, they have 4 friends and giving 3 pieces of candy to each. Same question applying. A student might think of it in 3rd grade, what we call the array model, and thinking about how this applies. There are 3 rows of chairs, and each row having 4 chairs. So how many people can sit and watch the performance? And this relates also to the area model here, and the context of that kind of relates to maybe a painting on a wall, right? That's 3 feet wide, 4 feet tall, and how much wall space would that painting actually take up? And the last way a student might think about this is think about this as a comparison. So a situation like this goes something like this. Lisa has $4 and Ryan has 3 times the amount that Lisa has. So how much money does Ryan have? Okay, so here are just a few ways that students might think about this in our classroom. And I wanted to pop up real quick that in this process of just getting their thinking out, that we are engaging students and you maybe in this process in the standards for mathematical practice. So number 1 is around making sense of problems and persevering in solving them. Number 2 is about reasoning abstractly and quantitatively, so making connections between the number 3 and the fact that it is friends, or that 4 stands for a number of pieces of candy I'm giving to each child or each friend. And then the last one is number 4, is model of mathematics. So we're asking students to use pictures in this case We might, in our classrooms, we might ask them to use counters or beans or something that is hands-on that allows them to move and make sense of that mathematics. So if as you think about how you did that, I will come back to the question of how might this have this been the same or different from the way that we experienced it growing up. Laura, did you want have anything to add here?
No, I think this is great. We're because this idea of having a visual representation that we're making connections between the context and the mathematical equation is just really important. And that would be true for elementary, middle school, and high school.
Thank you. So I'm going to move forward, and now that we've gotten some of the thinking out, another thing that we would do typically in our classrooms is to kind of focus in on a few of the ways that we're being, how the math was being thought about. And so as we go through this, I'm going to ask you to think about, just take a look at one of these two ideas that are on your screen. And then I'm going to ask you this question in thinking about them. Where do you see the 3? Where do you see the 4? Where do you see the multiplication being? And where do you see the answer? And so just take a minute to look at that and get a sense of how would you answer those questions. Oops. So I'm going to actually take a minute here to have Laura share with us how, as a pretend student of mine, to share with us how might she have thought about this. And so Laura, can you tell me, looking at one of these, how would you, which one did you think of, or first of all, the one on the left or the one on the right?
I was looking at the one on the left with the circles and the dots in the middle. And I saw the circles as being the 3 friends. Since there's 3 circles, that there was 3 friends. Okay. And then I was thinking about the candy as being the dots. So there's 4 dots within each circle. So that's the 4 pieces of candy. And then there would be 12 pieces of candy total.
And where did you see the 12? How did you come up with that?
The 4 dots in each of the 3 circles.
Okay, so what did you do with those 4s?
Well, I multiplied 4 by 3 in order to get to 12. But I know that students will sometimes think about it as 4 more, and 4 additional more.
Okay, so you might have thought about it as 4 plus another 4 plus another 4 to get to 12.
Yep.
Okay. And I just noticed right now that for some reason I was doing some inking on this that you are not seeing in yours. So, so she was pointing out here that we see the 1, the 2, the 3. We see the each dot standing for a piece of candy, each circle being a friend. Is that correct? And then the total being the 4 plus the 4 plus the 4. And so one of the pieces that we might think about here is how we, in this discussion and in thinking about the mathematics and how it's represented in the picture, we can think about a few other standards for mathematical practice that are in play here. So number 7 here is where we're looking for and making use of structure. So we're actually looking at what is the structure within the visual that provides some explanation for how the mathematics is at work. Number 6 is around attending to precision and thinking about the circle being the friends, the dot being worth a piece of candy, how we actually arrive at the number 12. And then the last one here is around critiquing and making constructing viable arguments and critiquing the reasoning of others in number 3. So it's oftentimes helpful for students to gain deeper understanding by looking at other people's thinking around the mathematics, because it gives, either they make a connection to it and say, oh, I thought about it that way, or they might say, that's an interesting way of looking at it, and that's easier than the way that I thought about it. Laura, did you want to add anything there?
No, I think that what you just touched on are the really important connections to the standards for mathematical practice. And I realize we're working with a 3rd grade task here, but thinking about those behaviors and those ways of interacting with the math is something we do want pre-K through 12.
And so you'll notice that we actually can, make some sense about the meanings of in this case, the factors and the product to help students understand multiplication and its usefulness in algebraic reasoning. So I want to shift our thinking just a little bit, and now to zoom out and take this out of the context of the student and think about this from your own perspective as an adult. I want to ask you to just take a couple seconds to consider, how is what you just saw Laura and I do with this mathematics the same or different from how you experienced the mathematics or math learning when you were in school? So if you have a comment on that, feel free to type it in the chat. Otherwise, just consider, how is this the same or different? So I see the comment made of much more rote and memorization. I'm assuming that that's something that many of adults we can identify with. The reason why I asked that question is we get asked a lot of this idea of what is it about this new math that kids are learning these days? And we make the claim that the mathematics is not new, but the way that students are being asked to interact with it is different, and that really comes out through engagement in the standards for mathematical practice. So that's why we continue to press on the importance of those. I want to call out that in those visuals that you were looking at, we were looking at the different situations that show the meanings of multiplication and division. And I believe it's page 2 or 3 of your document that this table lays out, and it's from the Common Core State Standards, that lays out what those meanings of the multiplication should mean, and that also considering that the unknown can be in different places, and that's something else that students need to make sense of. So I've seen the question of, is this consistent through Tacoma Online as well as remote learning? And yes, the standards for mathematical practice are applied to all K-12 students in Washington. So, but to take this just a little bit further, we might feel different. This is different from what we experienced because the emphasis oftentimes was on the following, either 1, arriving at the right answer, or 2, using a rule or procedure. And the standards for mathematical practice really ask students to develop deep understanding of these rules and procedures so that students know when to use it during problem solving and how to use them, right? And so, we contend that visual mathematics helps students develop deeper understanding of the math that underlies those rules and procedures that we know from our childhood. Again, another reason why we point that out. So I want to take just a couple minutes here to give you an opportunity to ask a question. So feel free to use the chat. Raise your hand if you have a question, and then I will go call on you as I see it pop up. But I'm going to just go silent for a minute here and let you frame your thinking.
Roy, this is Emily. I'm not seeing any hands up, but I appreciate the thoughtful pause here for people to think about the questions that they might want to type if they weren't willing to come on microphone, or maybe they're not in a place where they could ask it aloud. And so I just see a question that just came in. My 7th grader is struggling with the Tacoma online math portion. How can I best help her? So Ron, thank you for asking that question in the chat.
Yep, that's a great question. And so what I'm going to do is if I can finish up this next portion, because that's kind of addressing where we're going to go next, and then we'll have another couple minutes to ask the question or go a little bit deeper with that question if you would like to go further. So because it does lead to this question of what do I do? What do I do how can I help my child with their mathematics if I know it already, right? So one of the things that we contend to is about being curious about your child's thinking, right? So it's really about asking questions that help them to discover what do they know and where does the mathematics break down for them. So in the document that we shared, there is a I think it's a 4-page document that have 100 questions that promote mathematical discourse. So really, how can we talk with each other about the math? And in the document, you'll see that there are different colored talk bubbles, and each of the talk bubbles has a different purpose. So one of them may be in the green case here, is like if we want to work together to do the math, here are some questions that we would ask maybe as a teacher. But if we want students to rely on themselves, here are some questions that we can ask them to think about. Because it's so tempting to tell them what to do and tell them the rule that we know, but at the same time, we might struggle with understanding the mathematics that's in that rule or procedure ourselves. A great example that I come across all the time is when we divide fractions, we flip and multiply them. And when I ask adults, like, oh, why does that work? Most of us don't know why that works, but it works. And so, so trying to get students to understand that mathematics underneath of why flip and multiply works is really what we believe it means to do math and have that deep understanding of the math. Another thing that we can do is actually help students see the math visually, encourage them to draw the picture that they think that is represented in the math or in the situation, and have a talk about it. And try to make sense of where might this be going, because even if you know the answer by following the rule, sometimes it gets easier to explain by looking at the picture itself. Something else that we suggest that we hope that we can get everyone in Tacoma to do this is to look for math around you. So in the last pages of the document, there are some pages around math conversations in the community. That relates also to the website at the bottom, mathanywhere.org, that is coming out of one of our local service districts south of us. And it's really about how do we find mathematics in all around us, either at the store or at the park. How do we just bring the mathematics to life and visual and visible for our kids? But ultimately, Laura and I, we love math. We think it is beautiful and elegant, and there is so much joy in it for us that we hope that other people see it. So seeing the mathematics in the world around us, around town, or while we're around the house, or anywhere in nature, are places that we hope that the math comes alive, and we can just have a conversation and understand that mathematics is for everybody. One of the things that I would ask of all of us as adults is if you ever have heard someone say, or you've said yourself, I'm not a math person, that I would encourage you to stop. That if you feel like math wasn't for you when you were in school, my first thing is I say, I'm sorry, that's not your fault. We've learned so much about teaching mathematics and making it accessible to kids so that they can learn to love it like we do. That's what we want for all of our children. We just hope that you can find the beauty of mathematics with your children as well. So I have another point here to just stop and give you a minute to ask a question. So if you have something you want to pop into the chat box, or if you want to raise your hand, please feel free to do so. Okay, because I'm not seeing any questions or comments popping in, I'm just going to say that Laura did a great job in getting me prepared for today, and that we'll start to wrap things up for you. One of the things that, if you do have additional questions, we do suggest some people to contact more close to home for you. Obviously, your child's teacher. And then if there are other people at your school or setting that makes sense to reach out to. So that could be a counselor, it could be an assistant principal, support staff, or an instructional coach even. We do encourage you to reach out because we really want to support you and your children to make sense of the mathematics. We do have a survey link. Emily is going to drop that into the chat as well. We really appreciate your feedback. We would love to know if there was something we could do to add on to this session, or is there something we could do to improve this session? We really would appreciate the feedback because we are always trying to get better at what we do. We will stay on for another minute or two, but other than that, we're going to say thank you so much for taking time on your Monday. We appreciate all you're doing for your children, and we hope you have a great week. Thank you again for joining us today.